So if the first number is 10, the second number has to be 10 as well. Okay? All right, let's move on to the scalar matrix.
Sir, wait, I have another question.
Yes.
You see the diagonal one? Like that.
This one.
Diagonal could go any kind of way.
No,
So how about,
no. Diagonal. A diagonal means across.
No, I know, sir, but
Sir,
it
but it
could
could go
go
for the next
on
zero.
the other side, yeah. That
No,
one.
no,
Okay,
no,
next
no,
zero.
no. You were talking about this line? No.
No,
Yes,
sir,
sir.
but if it may have number, not the
That's
zero.
why it is not because when we talk about diagonal in this case, we're talking about the leading diagonal, meaning the diagonal that starts on the top left and ends in the bottom right. That's what we mean by diagonal. It cannot go the other way around. It can't go this way. Okay?
Yeah, so that
Okay,
like
sir.
just like a line with slant. Just
Yes.
imagine like a line with
Yes, and it has to go from here, notice to the camera, that way, to that end.
It has to go from that right to the
Yes,
to that
like that.
corner.
Yes, that. It has to be like that. Okay?
Yeah.
All right. Scalar matrix. A diagonal matrix whose all diagonal elements are the same non-zero, and that is why we call it a scalar matrix. So a scalar matrix, so let's look back. So this is compiling, if you notice. First we have a square matrix. Then we have a square matrix that only that line has numbers. That's called a diagonal matrix. Then a scalar matrix is a square matrix first. That is a diagonal matrix, but the diagonal has to have the same digit over and over and over again. All right? Notice here, 2, 2, and 2. So a scalar matrix, that number there has to be the same. Right? So a scalar matrix is a diagonal matrix, but a diagonal matrix may or may not have the same, may not be scalar. So all scalar matrix are diagonal matrix, but not all diagonal matrix are scalar matrix. Okay? So it's like you say, how can I put it? A Toyota, all right, a Toyota is a vehicle, but not all vehicles are Toyotas. All right? And that's what it's saying there. So all diagonals are scalar. I'm sorry. Yes, all scalars, my bad. All scalar are diagonals, but not all diagonals are scalars.
So that does say equal and equivalent.
Yes, it's the same thing with equal and equivalent. All equal are equivalent, but not all equivalent are equal. Same process. Yes, that's why we start with sets, because the principle of it will be the same. All right.